Hello everyone. In this video, we are going to discuss a topic based on ESP32 based real-time wind speed monitoring and the cloud upload. The objective of this particular task is that to measure the wind speed in the given area so that we can able to forecast how much wind energy can be produced in that area for each and every month. So this data can be fed to AI and machine learning algorithms to forecast the wind energy production in the future. So that is the idea. So we will see how it is being done, what kind of sensor is used, and how this data is being uploaded to the ThingSpeak server. Now let us understand what is this wind speed sensor is all about. So it is a sensor which has a small DC motor and a 3-cup type rotary wind cup. So its working principle is that when there is a horizontal wind flow in the environment, the rotary wind cup can generate rotation and drive the small motor to generate voltage. The rotational speed is fundamentally proportional. Using this signal voltage, the ambient wind speed can be measured. This wind speed sensor adopts the high precision wind speed sensor used by Naval Army, which differs from traditional products and has high accuracy. It is an indispensable wind speed detector in the fields of power generation, power station, meteorology, roads, environment, greenhouse, aquaculture, etc. So what it is actually, when the small generator is coupled with this rotary wind cup, whenever the wind flow takes place, the wind cup start rotating and the generator start producing the voltage which is proportional to the wind speed. So this is a basic idea. So the specification of this wind generator or the sensor is that it can measure from 0 to 56 meter per second. This is the range it can measure, and the cable length is given almost 10 meters length, and the dimension is given also here. The resolution is that less than 56 meter per second produces plus or minus 0.55 volt. So that is the resolution. And the wind speed sensor starting wind speed is zero point 0.7 meter per second. So that is the minimum speed required to start the cups to rotate. And the working environment temperature can be minus 30 degrees Celsius to 65 degrees Celsius. So these are the specifications. And the wiring connection looks like this is very simple, and we have only positive and negative terminal of this wind sensor. So the positive terminal is connected to any of these GPIOs. I have connected to G34, and it is the ground pin is connected to ground. Now let us discuss the program in detail. So the first step is that I have included the header files related to Wi-Fi module communication, and then the second part is that I have also added the Wi-Fi credentials like SSID password, and the third step is that I have declared ThingSpeak server settings, that is the server name and then API key and those things. And the next step is that about the anemometer setting, I have connected the anemometer into pin number 34, and these are some variables for calculating the wind speed. And in the wide setup mode, where we are going to begin the serial port and Wi-Fi and all those things is put up here. So in the loop, what we are going to do is that we are going to take a variable long ADC sum, and we are going to take 10 samples of the wind speed, and these samples will be added up, and then we are going to take a average of it. And after taking the average, we are going to calculate the wind speed using this formula. Float voltage is equals to ADC value divided by 40,095 into 3.3. So the operating voltage of this ESP32 is 3.3. So it is mentioned here 3.3, and the bit size of this particular controller is 4095. So I have taken it. So if you are using Arduino Uno, then you may have 1023. So it differs each and every controllers. Then there are some conditions. If voltage is less than minimum voltage, then voltage will be written as minimum voltage, and if the voltage is greater than maximum voltage, then voltage will be written as maximum voltage. And the speed calculation is given here. Float wind speed is equals to voltage minus minimum voltage divided by maximum voltage minus minimum voltage into wind speed. So this is the formula used here. So from here we will get the wind speed in amperes. So once we get the data, so we need to upload it in the ThingSpeak server here. Also, we are going to print it in the serial monitor here. So this is for the serial monitor, and here this line meant for uploading the wind speed in the ThingSpeak server. And that's it about the program. So it is a very simple program. So where we are connected the sensor and taken the data, and data is a sample for 10 times. So this number can be changed according to your requirement, and then taken as an average, then calculated the value. Then after that we calculated that value into wind speed, the converted into wind speed in MPS. Then we are uploaded the data to ThingSpeak and also printed in a serial monitor. Right. So this is the simple connection. So this is a wind sensor which I am talking about, and our ESP32 is here. So it is connected like this, and the output in the ThingSpeak server looks like this. That is a graph which we plotted with the data we obtained from this uh, wind sensor is plotted here. Let us see a simple video of it so that we can easily understand how it works.